Now we're going to take what we've learned about climate, air pressure, and winds and put it into understanding weather. What actually happens at a location. To understand that, you have to see air masses and fronts. Weather, as we've discussed, is a result of humidity, condensation, and pressure. And we've got global wind patterns that we've discussed before. Virginia, for instance, is in the westerlies wind belt. So, since we are in the westerly wind belt, our weather tends to move from southwest to the northeast. So when you're watching storms on the Weather Channel or WeatherBug, you can see the storms coming towards us. And here you can see this storm moving in our direction. What's carrying the storm? Well, that's an air mass. An air mass is a body of air that has similar characteristics. An air mass might be warm and dry, or it could be cool or wet. And it depends upon where it forms. There are 4 descriptors for air masses. Continental means it formed over a continent, so it's dry. Maritime, think marine, means that it formed over the ocean, so it's wet. Polar, formed near the poles and is cold. And tropical, formed near the tropics, the equator, and is warm. And we put these together. A continental polar would be dry and cold, probably forms over Canada, the CP. CT, continental tropical, dry and warm. Maritime polar, wet, cold. Maritime tropical, wet, warm. These are the air masses that affect the United States. Please fill them in on the diagram in your textbook. The ones near the top, notice, are all polar. They're coming in from the poles. The ones from the south are all tropical because it's warmer down there. The ones from the ocean are maritime and they bring moisture. And the ones over the continents tend to be dry. There are 4 that control our local weather here in Virginia: continental polar, maritime tropical, and continental tropical. Of these 3 to the right are the ones that control more of our weather. Continental tropic from Mexico doesn't make it this far all the time. So we've got heavily maritime climate, which keeps us more consistent and a lot more moist than we would be if we were further inland, closer to that continental tropical area. That's why on maps it tends to be green this side of the continent and drier to the west. Here is temperature map. These are isotherms. At the north, we have a colder continental polar air mass that formed over Canada and is heading south. Down here, we have a continental tropic air mass forming from Mexico. You can see the temperature variations between them. Now, in this particular case, the continental polar is winning. This cooler air mass is heading faster south than this is heading north. So this boundary between them, we call it a front. It must be a cold front because this cold air is moving in. It's the front of the cold. This is what we see on a weather map. The cold air mass is advancing south, bringing with it colder air. So once it just passed overhead, means that it brought us colder air. We had been warmer, the colder air came in. Fronts are the boundary between different air masses. And this is a typical formation for a low pressure, a storm in normal weather. You have a low, and the air around it is flowing counterclockwise. From the south, we get warm air, and so the front of that warm air is a warm front. From the northwest, we get cold air, and the advancing front of that is a cold front. So cold front. Please draw this symbol next to the description of a cold front. Also draw the arrow showing the direction it moves. Please leave it black, because most printouts will be black, not colored. It is pointy. You could think of it as teeth or icicles. They indicate a cold advancing air mass, and they point in the direction they are headed, just like an arrow. So on this particular one, the cold air is moving north. In this map, the cold air is moving southeast. In a side view, what's happening is the cold air is coming in and replacing the warm air. Since it is more dense than the warm air, it shoves the warm air up in the air, up higher. Warm rising air produces clouds, and thus we get precipitation at a front. This cold air moves very quickly, too, because it is moving along the ground, and it's easy to shove the warm air up. A warm front will look like this on a map. You could think of it as little half suns. And again, the little suns point the direction it is moving. So in this case, it is moving north. In this map, the warm front is moving northwest. Now notice the shape is different. Warm air is less dense than cold air, so it will always be on top of the cold air. As it's moving along, it's trying to push the cold air out of the way. So the cold air is being pushed to the left here. But it's also being pushed down into the ground. And it's hard to push air into the ground. So this warm air has to work very hard to push the cold air out of the way. So it moves very slowly. And it gets this very slow slope. So what happens is I'm standing at A and this front is coming my way. I'll start to see some high clouds. And then as it gets closer, lower clouds, lower clouds, lower clouds, until eventually I get some rain. But since, again, the warm air mass has to push the cold air into the ground, it goes a lot slower than a cold front does. This is important for producing the next type of front symbol. It's called an occluded front. If you look at the symbol, which again you should draw, it looks like warm, cold, warm, cold. Because what happens, notice they're all pointing in the same direction, is if I had a warm front and then a cold front caught up to it. See, here's my original warm front. It was warm air, cold air, and it was a long, shallow angle trying to shove the cold air into the ground. And it had a hard time doing that. So this cold front, came up in behind it and was able to catch up to it. This forced the warm air up again, giving you more rain. How does that happen? Alright, here's our typical normal storm. A low pressure with counterclockwise winds. We've got a warm front heading north and a cold front heading southeast. This warm front is kind of slow, and this cold front can move a lot faster. So it gets closer and closer, and eventually, kind of like a zipper, catches up entirely. So this gives us our occluded front. Finally, we have a stationary front. Notice there is no arrow showing direction because the cold front, in this case, is pointing north, but the warm front is pointing south. It can't go north and south. It's stuck. The two are battling it out, but neither one is winning yet. The warm front is moving to the left, and the cold front is moving to the right, and neither one is winning. So it tends to produce rain, and since it's stationary, it's not moving, it can cause floods. But eventually one of these two will win and power over the others. So these are our four fronts that you will see on a weather map: warm, cold, occluded, and stationary. And you'll see it on a map like this. When you compare one side of a front to another, the wind direction will change. For instance, warm front is heading north, so all the wind is going that way, and a cold front is heading southeast. So when it passes over, the wind will change direction. The temperature will change. When a warm front hits, we get warmer. When a cold front hits, we get colder. Very easy. And the dew point, meaning the humidity, will change. If warm air is replaced, warm, moist air is replaced by cold, dry air, then the dew point will drop. Keys to forecasting weather. First, you should know that storms move southwest to northeast in the United States. A low, a lousy low, tends to be stormy, and a high, happy high, tends to be clear. Precipitation forms near lows and along fronts. To see this in action, look at this map. H is high pressure, L's are low pressure. We have a cold front here, see the points, and it is headed southeast. A warm front heading northwest. A cold front headed southeast. A warm front heading northwest. A cold front headed east. Precipitation forms along lows and fronts. So, this is what we end up with normal meteorological symbols. These dots indicate rain near the low. These, what they look like, they're snowflakes. This interesting symbol is meant to look like an R for thunderstorm plus lightning. The symbol for a thunderstorm, right at a cold front. And along this warm front we have fog. That's what these three lines indicate. The high, nothing. High, nothing. And at this low, again, this is a symbol for rain showers, and this is a symbol for snow showers. So again, along lows and fronts are where we tend to get precipitation.